let's do some problems off of page 332, practicing what we know about quadratic functions and parabolas. On page 332, we find question number 10, which gives us this quadratic function in its vertex form. And we're asked simply to find the vertex. Find the coordinates of the vertex for the parabola defined by the given quadratic functions. Well, this particular quadratic function is in its vertex form. The vertex is very easy to find. This is a parabola that's shifted to the right 2 units and shifted up 12. And there's my nice happy vertex. But I thought I'd go on and graph this parabola just for the heck of it. And I'm going to think about transformations of functions in that vertex to do it. I'm counting by 2's on my x-axis and by 4's on my y-axis just for ease, but that vertex is up at 2, 12. Because of that minus out front, I know my parabola faces down. Alright, I want to think about the X Intercepts. I could plug 0 in for y and solve very easily, so let's just do that. Subtract 12 from both sides, and instead of being equal to 0, that would be equal to minus 12. I could divide both sides by a minus 3, giving me a 4. Take a square root of both sides, and I'd end up with plus or minus 2 is equal to x minus 2. So I need to add 2 to both plus 2 and minus 2. Well, that would tell me that x would be 4 or 0. There, my nice happy X intercepts. And a nice happy parabola graphed. Well, I've definitely seen worse, I've definitely seen better, but that's good enough for the purposes of this video. Of course, if I ever want to make a graph better, I could plot more points and actually use graph paper. Number 14 comes from the same section and has exactly the same instructions. Just simply to find the vertex. (3x squared minus 12x plus 1). Well, what I want to do is I want to show you how I can actually write this down in its vertex form by completing the square. To find the vertex, you could also just use the vertex formula. And I invite you to pause the video right here and use the vertex formula to find the x coordinate of the vertex and the y coordinate. Go on and do that. Okay, so I'm going to complete the square. So to do that, what I'm going to do is I'm going to imagine grouping the terms that have an x in them together. I've just left a space. I'm going to leave this 1 added in over here. And I'm going to imagine factoring out a 3. So that inside of these parentheses, I have an x squared minus 4x. On the outside, I still have this plus 1. The reason I've done that is to complete the square, I have to have a 1x squared. Alright, and I can't do anything to the other side of this equation because it's a y equals. And when I'm done, it still has to be a y equals. So I'm just going to let that 3 hang out there for a moment and only look inside the parentheses to complete the square. Minus 4 divided by 2 is minus 2. Squared is plus 4. I've definitely changed my equation. I just added 4 to it. But it's worse than that. Everything inside this set of parentheses happens 3 times. So I didn't really just add 4. I added 12. And again, I can't add 12 to the other side because I still want it to say f of x equals. So out here, where this 1's hiding out, I'm going to take away 12. Because if I add 12 and take away 12, nothing happened. I can now factor this perfect square trinomial into an x minus 2 all squared. Plus 1 minus 12 would give me a minus 11. Letting me write down the vertex as 2 comma minus 11. Well, that's all I was asked to do. I was asked to find the vertex. Now, when you pause the video and you use the vertex formula, I'm hoping what you said was, well, the opposite of b is 12. All over 2a is 6, and you get an x coordinate of 2. we plug that 2 into the function, and I'd have 3 times 4 is 12, minus 24 plus 1. So I end up with a minus 12 plus 1 is minus 11, and everything works out. In my handwritten solutions to these problems, I've graphed this one too. But the problem in the book only asks me to find the vertex, and I've done that 2 different ways. So I'm going to call this one done and move on to question number 16, which asks me again to find the vertex. Oh, I think it's a good idea for y'all, as soon as I finish writing down the problem, to pause the video and use the vertex formula to find that vertex. I'm going to go about it the same way I did last time, where I complete the square. Alright. So again, I'm going to group the things with an x. I'm going to factor out a minus 2. I'm still going to have that minus 1 out here. On the inside of the parentheses, I'll complete the square, so minus 4 divided by 2 is 4. Divided by 2 is minus 2 squared is 4. And now I need to undo what I just did. But this time when I distribute, I have to remember that everything in this side of parentheses gets multiplied by minus 2. So I didn't add 4. I took away 8. So I need to think about adding 8 to undo that. There's the vertex form. So my vertex is at 2, 7. And again, in my handwritten notes, I've graphed it, but here we were just asked to find the vertex, and we've done that. And if you pause the video and use the vertex formula, you would have said the opposite of b all over 2a is minus 8 all over a minus 4, which is 2. Plug that 2 into the function, and we, let's see, get a 4, that's a minus 8 plus 16 minus 1, and that is 7. So you get the same vertex using either method, and that feels good to me. The next one on my list is number 26. Alright, so we've done 16, and now it's off to number 26. The instructions this time: use the vertex and intercepts to sketch the graph of each quadratic function. Give the equation of the parabola's axis of symmetry, and then use the graph to determine the function's domain and range. And in number 26, we're given f of x equals 1 minus x minus 3 all squared. Well, the first thing I'm going to do is write this down in that vertex form, where I'd prefer to say minus x minus 3 all squared plus 1. Well, let's write down the vertex. That's going to be at 3, 1, right? Just looking there and there. That minus 1 out front, right? That minus really a minus 1 times. Tell me that this parabola is going to face down. All right, well, I'm asked for the intercepts. Set the function equal to 0 to find the x intercepts. You can imagine adding this to both sides to get an x minus 3 squared equal to 1. If I take the square root of both sides, I'll get x minus 3 equals plus or minus 1. So to find x, I will be adding a 3 to 1. That would give me a 4. And I'll be adding a 3 to a minus 1, which would give me a 2. So my x intercepts are 2 and 4. I always like writing those down as ordered pairs. So I have x intercepts at 2, 0 and 4, 0. I need a y-intercept, so I'll be plugging 0 in for x. And if I look at this original statement, I have 1 minus a minus 3 squared is 9, giving me that y-intercept at minus 8. Alright, so there is my y-intercept. Now I can sketch my graph and answer the rest of the questions. want that vertex up at 3, 1, 1, 2, 3. So 3, 1. Didn't need to count so many on the y-axis. Don't know why I did, but that's okay. 2, 0, 4, 0, and then finally the y-intercept all the way down here. Handwritten solutions don't even include that because it was so far away. But here where the internet will let this live in posterity, we'll find everything. Alright, so there's my nice happy parabola in number 26. I'm asked for the axis of symmetry, always running through the x-coordinate of the vertex. So the axis of symmetry is at x equals 3. And finally, a domain in a range. Well, quadratic functions have domains that are all real numbers, and ranges that either start or end at the vertex. This one faces down, so it comes up from minus infinity all the way to y equals 1. And there's our nice, happy domain and range in question number 26. All right, let's take a look at number 38. Question number 38 has the same instructions. And again, I think I'm going to rewrite this equation so that it's in a format I like a little better. So x squared minus 4x plus 6, descending by degree. And here again, I'm given the same instructions. So I'm going to find all the intercepts and all that other stuff, and then graph a picture, state a domain, and range. Well, I'm just going to use the Vertex Formula. Opposite of b is 4 over 2 times 1. So the vertex will just have an x-coordinate of 2. I need to plug 2 in the function to find the y-coordinate, so I need to find f of 2. Well, that would give me 4 minus 8 plus 6. Vertex is going to be at 2, 2. I need to find some intercepts. My x-intercepts happen where the function's equal to 0. Use the quadratic formula here. Opposite of b plus or minus the square root of b squared. 16 minus 4 times a times c. All over 2a. Well, right here I could stop because I actually see I get a negative under the radical. But just for the practice, I'm going to write out what I get. 4 plus or minus the square root of 16 minus 24. Minus 8 over 2. 2 plus or minus I, and that would be 2 root 2 divided by 2, so just a root 2 there. These complex numbers are not x-intercepts. They are solutions, but not x-intercepts, so this has no x-intercepts. Alright, find a y-intercept, and then we'll sketch our graph. F of 0 is 6, so my y-intercept 0, 6. Alright, well, I have a vertex, 2, 2. I have an intercept, 1, 2, 3, 4, 5, 6. Oh, I know I could go over 1, up 1 on this transformation of the graph of y equals x squared. I also could imagine where that corresponding point on the other side of the axis of symmetry would be. But I end up with this nice happy parabola. I have an axis of symmetry at x equals 2. The domain of a quadratic function is all real numbers. And the range, parabola faces upwards, it starts at y equals 2 and goes on forever. Oh, that's a beautiful thing. And looking at the graph, I see why there are no x-intercepts, right? It faces up and doesn't hit the x-axis at all. So that's a nice, happy graph. So that was problem number 38. There are 3 more problems I want to do in this problem set, but I'm going to post those in a separate video because my recorder is getting ready to run out of battery, and I'm going to charge it for a while.